Hello, Geography 232 students. Welcome to week 13 of our class. We are coming down the home stretch. So last 2 weeks, we've spent time talking about Model Builder, how to design and implement a model in the kind of visual, what you see is what you get, Model Builder environment. This week, we're going to transition to Python scripting. And so this is a very introductory, superficial introduction to Python scripting in the context of GIS. All the scripting that we'll be doing will be in ArcGIS Pro. Anything we learn today, you can apply in an integrated development environment, an IDE. So even though we'll be limited to ArcGIS Pro, you can take these skills and apply them outside of the GIS context. All right, so this week's lecture notes, getting to know Python. We will have a reading this week, Beginner's Guide to Python. It's fairly short. I'll upload that to Canvas. And the lab will be Intro to Python Scripting. And again, it's going to be a fairly kind of brief overview of how do you get started scripting in ArcGIS Pro. We'll introduce concepts of variables, how to run variables, and things like that. Upon completion of this lecture and lab, you should understand the history and utility of Python, fundamentals of Python, including data types and syntax, how to use the Python prompt and transcript window, and how to execute basic Python commands. And this is part 1 of 2. We'll have a second lecture on Python next week. So if you're watching this on YouTube, feel free to check out part 2 as well. All right, a brief overview of this lecture. First, we'll talk about why Python. Why do we use Python? What are the benefits and perks? A very brief history of Python. So first of all, you might be wondering, why is it called Python? We'll talk about that briefly. Fundamentals of Python, Python editing, and writing and running code. All right, first, why Python? Python is a programming language that's both simple and powerful. Hooray! It really is it really is a program that is, I would say, if you ask any computer programmer, they would say Python is a very good entry-level programming language. But that's not to demean it and say it's less capable than any other. It's actually a very capable language that is both accessible for GIS users and others, and it's applicable in the database management environment. So you can take it outside of just GIS, and you can take it into SQL and other sorts of environments where you are going to be using object-oriented languages. Python is an extremely useful language for GIS users since many GIS software platforms, including ArcGIS, obviously, QGIS, which is open source, PostGIS, and others, rely on the language for scripting. And scripting is it's a collection of commands in a file designed to be executed like a computer program. So essentially, you're telling the computer what to do when you write a script and implement and run a script. So the examples here, you're telling the computer, in this case of the GIS, that A equals 12, B equals 26. So those are variables. You define the variables, and then you tell it to multiply A times B. And you can also do if-then statements and many other commands. So Python is the language of choice for GIS because it's simple and it's easy to learn. So it's relatively easy to learn compared to more complex, highly structured languages like C++, Visual Basic, and others. And the syntax is simple, logical, and user-friendly. So as I said before, it's a really good introductory language that is not introductory because it's less than or it's inferior to others. It's actually very versatile, and it can be used in many different environments. And it's also a good stepping stone if you do want to learn more advanced languages. Another benefit, a reason why Python is a language choice of GIS, is because it's free and open source. So Python is a free and open source software. It was developed by a handful of developers in the early 90s, and it's been taken on by an international consortium of developers since then. And there are yearly conferences, and there's just virtually limitless documentation on the internet of how to do this, that, and the other. So it's a highly supported open source language, and that means it's been taken up by many different platforms. As a free and open source software, there are many programs and platforms on which to learn and use Python. Another reason why Python is a language of choice for GIS is because it is cross-platform. So it's supported by Windows, Mac, Linux, and other platforms. Python programs work on these platforms with minimal changes and sometimes none at all. And while most GIS is Windows only, Esri, obviously, and others. Python users are a big community across many different operating systems and disciplines. So if you can learn Python, it opens the door to other, applications, other platforms on which to learn, and it allows you to learn it outside of a Windows specific environment. So obviously, when you're using Esri software, you have to either have a Windows machine or a dual booted Mac. If you want to learn Python, you can find myriad different integrated development environments that run in Mac, on an Apple computer, in Linux, if that's your thing, and so on. So you're not trapped in the Windows environment. Another reason why Python is a language of choice for GIS is because it's an interpreted language. Unlike C++ and Visual Basic, which need to be converted to binary via a compiler, Python is an interpreted language. So essentially, what you see is what you get. Interpreted languages don't need to be compiled into binary to run, which means it's easier to go back and edit your script, to make changes, to modify it on the fly, and it's a time saver in that sense as well. Because apparently, compiling language scripts is a very time consuming and sometimes treacherous process. And finally, Python is a language of choice for GIS because it's object oriented, which is the same as GIS. So object oriented programs involve a collection of interacting objects as opposed to the conventional list of tasks. So when we talk about objects, we're talking about in the GIS environment, points, lines, and polygons, where what you see on a screen, let's say in the context of a point, there's also a record in a table. Okay, so when we're talking about Python, each of these commands is essentially an object, and each of these variables is an object, and it's all about how these variables interact with these commands. So many modern programming languages support object-oriented programming, and ArcGIS is designed to work with object-oriented languages, thus Python is its language of choice. All right, a very brief history of Python. So Python was created by Guido van Rossum at the Centrum voor Wiskunde en Informatica. That's the Center for Mathematics and Computer Science in the Netherlands. It was first released in 1991. Van Rossum remains active in the ongoing development of Python, but since it's an open source language, its development is actually carried out by thousands of developers around the world, and there are continually minor updates, and there are these packages of different commands that you can download and access, and it's become a virtually limitless language that can do many different things within and outside of GIS. The name Python is not a reference to the snake itself, but to the Monty Python comedy troupe. And I personally am a huge fan of Monty Python. And so if you go to the next slide, you'll find a couple of links to my favorite sketches, and these are mostly songs here. And so you can check those out if you are a Python fan. If you've never been introduced to Monty Python, now's your chance. You will not be disappointed. All right, the fundamentals of Python. So Python, like all programming languages, relies on basic syntax. So syntax is essentially the structure of language, and that's both in the language that we speak and the structure of the language that we input into computers, right? So Python syntax is comprised of numbers and strings, which are text, variables, statements and expressions, functions and modules. These components can be combined together to create conditional statements, so if then, branching, and loops. So all of these are part of the basic syntax, which again in Python is fairly, I wouldn't say rudimentary, but accessible. All right, the fundamentals of Python, data types. Python uses several data types, including, as I said, strings, numbers, lists, tuples, dictionaries, and more. The data type of an object determines what type of values it can have and what operations can be performed on an object. So think about in the context of GIS, when we create a new field in an attribute table, we have to choose the type, right? So the type of field, is it going to be a numerical field? Is it going to be a text string? If it's numerical, will it be a short integer, long integer, a float, double precision? And there's also binaries and other things like that. So each of those, what they do is they determine the type of values that can be input into that field in an attribute table. And the same thing applies in the context of Python. So the data type of an object determines what type of values it can have and what operations can be performed on that object. So strings consist of one or more characters, which can include numbers, letters, and special characters, and they have to be in quotes. All right, so that means that if you've got a string within quotes and it's, we'll say 1 plus 1, it doesn't equal 2. It literally just means 1 plus 1 because it's text. It's not numerical. Numbers, on the other hand, can be integers, which are whole numbers, 1 plus 2 in this case, or floats, which are fractional values. So 1.0 plus 2.0, okay? Lists, tuples, and dictionaries are more complex data types that consist of collections of data elements, and we won't really get into those. We will get into arrays later on, but we will not get into tuples and dictionaries. Numbers. So since numbers can be integers or float, they act differently depending on the Python syntax. So consider the difference between these scenarios. So 3 times 8 equals 24, right? So if these are just integers. So the results are the same no matter what the type of number. It's always going to be number times number and then the product. Now consider 7 divided by 3. If the data type is integer, like a whole number, the result will be 2. Why is that? Well, because the output, or the quotient in this case, has to be a whole number or an integer. So in order to actually get the precise number, the value needs to be a float, meaning it has a decimal place. And that can be anywhere from 0 decimal places out to some very high number of decimal places, a high precision. So consider the difference between 7 divided by 3 as an integer versus 7.0 divided by 3.0. When it's considered a float type, data type, the quotient is going to be 2.333333 because the resulting numbers can be fractional. So just keep that in mind when you're considering data types. Consider what output you are looking for. Variables. So Python scripts use variables to store information, and sometimes this is to save keystrokes essentially. Like let's say you've got a very large numerical value, you can just say x equals very large numerical value. Then in the future, you just need to type x, right? So variable is essentially a placeholder for a value. This example here is x equals 17. So the variable x is a placeholder for the number 17, but it could also be a placeholder for the number 3,700,000,000,600,000,000, something, right? So just think about it as a time saver and to save you keystrokes. The above is called an assignment statement, by the way. When you assign a variable to some sort of defined value, that's the assignment statement. Once a value has been assigned to a variable, you can use a variable in an expression or any number of expressions. So my examples here are x equals 17. So x times 2 would be 17 times 2, 34, right? There in the middle, x equals 17, y, we have another variable, a second variable, y equals 100. X times y equals 1700. And finally, we have a conditional statement, an if-then statement, which we'll get into a little bit more in a second. If x is less than y, print this is fun. So in this case, we know that x equals 17, y equals 100. So if 17 is less than 100, which it is, print this is fun. And this is fun is a text string. And so you hit enter in our Python window, and we see the words this is fun are printed. All right, so now it's sort of showing we're transitioning over to strings. Strings are text. A set of characters surrounded by quotation marks is called a string literal. All right, so consider this example in which the variable text equals quote GIS close quote. In the above example, GIS is called a string literal. Okay, and text, the word text is actually the variable in this case. Now, the variable could be X, it could be Y, it could be geographic information systems, it doesn't matter. What you're doing is you're choosing some sort of variable and then defining it in the assignment statement. And in this case, the variable equals GIS. So quotation marks tell the program where the string starts and where it ends. So open quote, enter your text, close quote, that would be your text string. So just like numbers, strings can be combined with variables and connected into blocks of code, and we call this concatenation. So in this example here, x equals g, y equals I, z equals s, print x plus y plus z, and the output is GIS. All right. So again, we can use variables just like with numerical values in this case. All right, briefly on Python editing. So in order to edit your Python, you need some sort of terminal, some sort of a window into which you'll be typing in the text and then running it and seeing what the output is. So a script is essentially a list of commands that can be run by a program or script engine. Scripts are typically just plain text documents like a .txt file, or they might have a specific file extension depending on the input where you're going to be using it, and they will also contain instructions in a specific scripting language for the platform. Script editing can be done in an integrated development environment. As I mentioned at the beginning of the lecture, there are many different types of IDEs. Many run in Windows, some run in Mac, some run in Linux, and so on. So just know that there's no shortage, and I actually have a link here in the lecture notes, a Wikipedia article with a list of a pretty expansive list of Python editors or IDEs. All the editing that we'll be doing in our class will be in ArcGIS Pro, because ArcGIS Pro and ArcMap has its own development window. All right, so you don't need a standalone IDE. You can actually use ArcGIS Pro, which is pretty handy. So just be aware of that. All right, and finally, writing and running code. So Python code is executed one line at a time. Now, the results are displayed immediately, and in the ArcGIS Pro Python window, and really in any integrated development environment, you essentially have two components to the terminal. You have what's called the prompt and the transcript. The prompt is where you actually enter your text line by line, and the transcript is the transcript of all of the lines of code that you have entered. And so you'll know that some code blocks require multiple lines, and we'll talk about how to handle that. But generally speaking, every single line is an actual executable. Every time you hit enter, you're executing, telling the terminal that you are giving it a command and to make sense of that command. So in the example to the right here, we see 3 commands have been written. We have A equals 12, B equals 26, and multiply A times B. All right, so variable A equals 12, variable B equals 26, and multiply A times B, and then it gives you the product. A times B equals 312, because 12 times 26 is 312. So each line of code here is a command. It's telling the computer A equals 12, right? That's the assignment statement. B equals 26. And then A equals B. That's an executable mathematical formula that Python says, oh, I can do that on a calculator, right? So that's one of the great sort of introductory tools that you can use right off the bat with Python. In this case here, the example has 2 commands. It's working with text strings. So first we have our variable, which is the word text. But again, in this case, your variable could be anything. It could be X, it could be Y, it could be geographic information systems. It doesn't matter. You're essentially defining a variable, and the variable can be anything. So in this case, text equals open quote, GIS, close quote. And then we're telling the Python platform here to print the variable, which is text. So we say, this is what the variable is, it's GIS. Now print the variable, and then output is GIS, right? And when we say print, in the context of programming, what we're saying is essentially display for viewing. You press enter at the end of each line of code to execute the line. All right, so as I said, every single line is an executable piece of code. Any result is printed to the next line, and the following line starts with a new command prompt. Think of hitting enter as the equivalent of running a new tool in ArcGIS. So every single line is an executable. However, in some cases, a single line of code cannot be executed because it's part of a multi-line construct. Okay, that's a key term here, multi-line construct. And you'll know that a lot of large code blocks are multi-line constructs. You aren't going to find very many single-line constructs in more advanced programming scripts. So in this example here, we have an if statement. So the if statement to the right is part of a multi-line construct. And you know, if you have the word if, you know there's going to be some following statement or clause, right? So come to my house if you like cupcakes, because I made cupcakes, or let's go to school if you are still a student, or go ahead and listen to this lecture if you are interested in learning Python, right? So you know that if is essentially a conjunction in this case. It's linking 2 different clauses together. So there has to be at least one additional line of code for it to be executable, and the hint here is the colon. Notice the colon to the right. So if A is less than B, colon, that's the second clause. It's saying there must be something following that, okay? So the if statement signifies the beginning of a block of code. Therefore, the next line needs to be, and automatically is, indented. So you don't have to worry about hitting tab or a bunch of spaces. If you do an if statement or any other sort of multi-line construct, it will automatically indent it for the following clause. All right, so that concludes our very superficial introduction to Python programming. Tune in next week for part 2, and we'll learn a bit more. For this week's lab, for this week's reading, we have an assignment called Beginner's Guide to Python, which is kind of a fun introduction. It's actually like a blog post from Esri from a couple of years ago, and I think it's a good kind of introduction to understanding the mechanics behind Python and how it's useful. Our lab is Intro to Python Scripting, and it's several pages. Give yourself plenty of time, just because you're going to get used to using Python potentially for the first time. But at the end of this lab, you'll see an assignment. It'll just say assignment. That's what we have on screen here. And so walk your way through that. By the time you get to that point of the lab, you'll know how to construct what I am looking for. And so for the actual submission, go ahead and copy and paste the final transcript into Canvas for credit. You can either take a screenshot or literally copy and paste the text and paste it into Canvas. So that will be the assignment that I'm looking for. So on that note, have a great week. Until next time, bye-bye.